Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Hafizur Rahman bin Zulkifli, nombor metik 13 DEP20F1043 dan di kumpulan saya Muhammad Daniel bin Tahir, nombor metik 13 DEP20F1022 dan Cik Wang Nadimi Muzammil bin Cik Wang Adenam, nombor metik 13 DEP20F1010. Hari ini saya akan menerangkan EOC 1. Topik 1. Introduction to Semiconductor. Definition of semiconductor. A material that has an electrical conductivity that is between that of a conductor and an insulator. Semiconductor device can display a range of useful properties such as passing current more easily in one direction than the other, showing variable resistance and sensitivity to light to heat. Semiconductor material has 4 electron valence. Example of semiconductor: silicon and germanium. Silicon is critical element for fabricating more electronic circuits. Both silicon and germanium are semiconductor and contain 4 valence electrons. Silicon is chapter and can be used at high temperature to conduction heat and electrically. Silicon can accept more overheat before charged to conductor. Silicon less easily damaged by heat when soldering. Silicon has very low leakage current when reverse voltage. Germanium high leakage. P-type and N-type characteristic. Intrinsic semiconductor. Pure semiconductor, no impurity has been added. Example: germanium and silicon. Extrinsic semiconductor, pure semiconductor plus impurity. This process called doping absorption process. Two categories of impurity: trivalent and pentavalent. Example: trivalent 3 valence electron, aluminium, boron, gallium. Pentavalent 5 valence electron, antimony, arsenic, phosphorus. Two categories of impurities: trivalent. Example: aluminium, boron, gallium. Product: P-type semiconductor. Pentavalent. Example: antimony, arsenic, phosphorus. Product: N-type semiconductor. Formation of N-type. Pure semiconductor, silicon plus pentavalent atom, in bracket arsenic. This creates an excess of negative N-type electron current carriers. The electrons are the majority carriers, while are the minority carriers in N-type materials. Formation of P-type. Pure semiconductor, in bracket silicon plus trivalent atom, in bracket indium. The purpose of P-type doping is to create an abundance of hole. A hole behave as a quantity of positive charge. The hole are the majority carriers with electrons are the minority carriers in p-type material. P-N junction. A p-N junction is formed when a n-type and p-type semiconductor are joined together. The boundary between the p-type and n-type region is called the junction. At the p-n junction, electrons from the n slide move to the p slide and recombine with the hole. Holes from the p slide similarly move into the n slide, where they recombine with electrons. As a result of this flow, the n slide has a net positive charge and the ps has a net negative charge. Threshold voltage. Voltage level where the increment of current happens when the applied forward base voltage reaches the barrier voltage. Threshold voltage for diode: silicon 0.7 volt, germanium 0.3 volt. Two types of base voltage. First, forward base. Second, reverse base. This is an example forward base. Forward base. The p-type is connected to the positive terminal and the n-type is connected to the negative terminal of a battery. Electrons in n-type material will move forward to the junction that cause the depletion region become narrow (smaller). The value of current will increase and resistance will decrease. This is an example reverse base. Reverse base, the n-type is connected to the positive terminal and the n-type is connected to the negative terminal of the battery. The reverse polarity causes a very small current to flow about electron and hold a pole away from the junction. The electron in n-type is attracted to positive terminal and will cause the depletion layer become larger. The resistance become higher, current cannot flow.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Daniel bin Tahir. Saya akan memutarkan topik 2 iaitu diode. Physical Structure and Symbol. Di sebelah kiri kita boleh tengok physical untuk diode dan di sebelah kanan kita boleh lihat simbol untuk diode. N-type material is called cathode K. P-type material is called anode A. Forward bias. Anode is connected to positive supply. Cathode is connected to negative supply. When forward bias, current can flow through the diode and a switch is switched on. Reverse bias. Anode is connected to negative supply. Current cannot flow through the diode, like the switch is switched off. Knee voltage. Voltage level where the increment of current happens. When the applied forward bias, voltage reaches the barrier voltage. Knee voltage for diode: silicon 0.7 volt, germanium 0.3 volt. Ideal diode concept. Forward bias. Diode has the closed switch or on because no resistor and voltage drop. Reverse bias. Diode has open switch or off infinity resistance. Rectifier. Rectifier, when use one or more diode, cut half of negative circle or half of positive circle. Convert alternative current to pulse rippling direct current. And three types of rectifier. The first one is half wave, full wave, and bridge. Wave rectifier. This is the example for half wave rectifier circuit. Okay, the next one is full wave rectifier. This is the example for full wave rectifier circuit. Okay, the last one is bridge. As you can see, this is the example for bridge circuit. Types of diode. We have four types of diode. The first one is Zener diode. Second one is light emitting diode, or we usually call it LED. The third one is photodiode, and the last one is laser diode. Zener diode. Zener diode used to produce a stabilized voltage output or voltage regulator. Type of diode that permits current in forward direction like a normal diode, but also in the reverse direction if the voltage is larger than the breakdown voltage, known as Zener voltage. A Zener diode is much like a normal diode, but it is placed in the circuit in reverse bias and operate in reverse breakdown. Light emitting diode, or LED. Characteristic of LED. The light colors depend on the type of the material. First one is GAAS. It's produce infrared. The second one is GAP. It's produce red and green. And the last one is GAASP and produce red and yellow. Photodiode. Photodiode characteristic. Photodiode is a type of photodetector capable of converting light into either current or voltage, depending upon the mode of operation. Photodiodes are used in consumer electronics devices such as compact disc player, smoke detector, and the receiver for remote control in VCRs and television. Laser diode. The word laser stands for light amplification by stimulated emission of radiation. A laser diode, also known as injection laser or diode laser, is a semiconductor device that produces coherent radiation in which the waves are all at the same frequency and phase. In the visible or infrared (IR) spectrum when current passes through it. Laser diodes are used in optical fiber systems, compact disc CD player, laser printers, remote control device, and intrusion detection system. Laser diode characteristic. Small size and weight. A typical laser diode measures less than 1 mm across and weight a fraction of a gram, making it ideal for use in portable electronic equipment. Second one is low current, voltage and power requirements. Most laser diodes require only a few mW of power at 3 to 12 volt DC and several milliamperes. Therefore, they can operate using small battery power supplies. The last one is wide angle beam. A laser diode produces a cone rather than a pencil of visible light or IR, although this cone can be cool-limit using convex lens.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cik Wan Nadimi Muzamil bin Cik Wan Denan. My metric number is 13 DEP20F1010. Today I'm going to present about topic 3, bipolar junction transistor, or we call it BJT. First is transistor, a three-terminal device whose output current, voltage and or power are controlled by its inputs. In analog circuits, transistors are used in amplifier and linear regulate power supplies. In digital circuit, they function as electrical switch, including logic gates, random access memory, RAM, and microprocessor. As we all know, transistor has two types of it, which is first is BJT, bipolar junction transistor. Second is FET, field effect transistor. Next, I'm gonna talk about some difference BJT and FET. First, we have control method, input current IB or IE. In FET, input voltage VGS. Second is bias type of input circuit at active mode. In BJT, forward bias in base B and emitter E junction. FET reverse bias in source S and gate G junction. Third is the gain. In BJT, example voltage gain. In FET, example mutual transconductance. Last, I choose as randomly is current on paths. Immediately, current move between emitter and base and collector 3 paths. In FET, current move between source and drain 2 paths. 3 layer in BJT collector. Base very thin, has fewer doping atom base. Emitter 2 type of BJT. PNP figure on left, operate with outgoing base current. NPN figure on right, operate with incoming base current. This is some BJT schematic representation of example. BJT structure. The BJT is constructed with 3 doped semiconductor regions separated by 2 PN junction. The 3 regions are called emitter E, base B, and collector C. The BJT have 2 types. First, 2 N regions separated by a region called NPN. Second, 2 P regions separated by a N region called PNP. The PN junction join the base region and the emitter region is called the base emitter junction. The PN junction join the base region and the collector region is called base collector junction. The base region is lightly doped and very thin compared to the heavily doped emitter and the moderately doped collector region. This is how we calculate the current. The formula is IE sama dengan IB plus IC. The direction of the current is NPN transistor and PNP transistor are shown in the figure. The emitter current IE in the sum of the collector current IC and the base current IB. IB, IE or IC, the capital letter DC value. Transistor is a current control device. The value of collector and emitter current are determined by the value of base current. An increase or decrease in value IB cause similar change in value of IC and IE. IC, B, DC, IB. Current gain B, factor by which current increase from base of transistor to its collector. Next, we're gonna talk about transistor voltage. VCC, collector supply voltage. This is a power supply voltage applied directly to collector of transistor. VBB, base supply voltage. This is DC voltage used to bias base of transistor. VEE, emitter supply voltage. DC biasing voltage, and in many cases VEE is simply a ground connection. VC, DC voltage measure from collector terminal of component to ground. VB, DC voltage measure from base terminal to ground. VE, DC voltage measure from emitter terminal to ground. VCE, DC voltage measure from collector to emitter terminal of transistor. VBE, DC voltage measure from base to emitter terminal of transistor. VCB, DC voltage measure from collector base terminal of transistor. The last one is terminal and operation. 3 terminal. Base B very thin and lightly doped. Central region little recommendation. Emitter E and collector C are 2 outer regions sandwiching B. Normal operation linear and active region. B, E, junction forward bias. B to C, junction reverse bias. The emitter emit inject majority charge into base region, and because the base very thin, most will ultimately reach the collector. The emitter is highly doped while the collector is slightly doped. the collector is usually a higher voltage than the emitter. That's all from me. Thank you.